Very well. So in this example, question says, find the volume of a solid that lies above the cone phi equals to pi over 3 and below the sphere rho equals to 4 cosine phi. Let's take a look at this. We already know we are dealing with a sphere. So let us apply spherical coordinate system, right? To apply coordinate system, what do we need? We need to have the volume, which is equal to the triple integral of dv. Well, we need to know what is the boundary for our rho, what is the boundary for our phi, and what is the boundary for our theta, right? So this guy can be written as the integral of rho squared sine phi d rho d theta d phi, or d phi d theta, it doesn't matter, you can switch in between. You have a cone, it means that your phi is bounded between 0 and pi over 3. You also have a sphere, it means that your rho is bounded between 0 and 4 cosine phi. Very good. Remember that you can convert these all into x, y, and z and visualize them if it's easier. If I multiply both sides by rho, I get rho squared equals to 4 rho cosine phi. Perfect. Remember the definition of rho squared. Rho squared is defined as x squared plus y squared plus z squared. And on the other side, you have the definition of rho cosine phi. Remember, we define rho cosine phi to be z. So you have 4z. You can bring this guy to the other side and complete the square. You get x squared plus y squared plus z squared minus 4z equal to 0. Or x squared plus y squared plus z squared minus 4z plus 4 equals to 4. You can use these three terms to complete the square on one side. X squared plus y squared plus z minus 2 to the second equals to 4, or 2 squared. So as you can see, you have a sphere with center 0, 0, and 2, and radius equals to 2. So you can convert everything from rho and phi into x and y and z as well. Perfect. So my volume is equal to, I know that my theta is bounded between 0 to 2 pi. My phi is bounded between 0 and pi over 3, and my rho is bounded between 0 and 4 cosine phi. And I have rho squared sine phi d rho d phi d theta. The volume becomes, well, we don't have any theta involved here, so I can separate this 0 to 2 pi d theta multiplied by the integral here. I get integral 0 to pi over 3, and here I have rho squared, which becomes a third rho cubed sine phi, and my rho is bounded between 0 and 4 cosine phi, and here I have my d phi. Perfect. So what do we see here? The rest of it, this is going to be just 2 pi. And here I have a third. Let's write down the whole thing, 0 to pi over 3, a third, and I have 4 to power 3, and I have cosine to the third of phi multiplied by sine phi and d phi. Here I can use u sub, u is equal to cosine phi, and du is equal to negative sine phi d phi. So this guy becomes the volume 2 pi over 3 times, okay, here we have 4 to the third. I write it this way, maybe I can simplify later. Remember that here I have cosine to the fourth, so I can borrow one of these 4s here, and I get 4 to the second power, and here I have, let's see, cosine to the fourth pi, and here I have 0 to pi over 3, and I need a negative sign as well. So let's see if we can simplify this more. I have negative 2 pi times 16 divided by 3, and here you have cosine of pi over 3, which is a half, so you have a half to the fourth minus 1. Okay, so we can simplify this more. You have 2 pi or 32 pi over 3 times 1 minus 1 over 16. We can do the algebra and take the common denominator between these two, 48 and 32 pi, and here you have 15. So if we do the multiplication, 32 times 15, or can we simplify this more? So we can simplify this a little bit more, 24, and here you have 16, and then you have a 4, a 6, a 3, and a 2, and this guy is going to be 5, so it's going to be 10 pi.